This is lesson 1-2, inverse functions of algebra 2. The goal today is to evaluate inverse functions from a table, a graph, and an equation. You may be asking yourself, well, what is an inverse function? Well, an inverse function just undoes the mathematics that a function does. So for example, if f of negative 2 on the graph is 4, and it is, then we would say that f inverse of 4 is negative 2. It just works its way back from the output to the corresponding input. So f of 0 is 3. So if you go to 0 on the graph and go up, you're going to see the y value is 3. Well, then f inverse of 3 would just be 0. It just takes us back to the input. So f of negative 1 is 3.5, and then f inverse of 3.5 then would be negative 1. Now f of 2, that's kind of interesting. F of 2 is negative 1, but f of negative 1 actually has 2 values associated with it. You know, f of 3 also does. And f of negative 2, f of 4 does not. So 3.5. F of negative 1 is 3.5. Yeah, there's 2 corresponding values there too. So each of these would actually have an additional corresponding value. So f inverse of 3 means you're starting at 3, and 0 gives you 3, but also this negative 2.5. And then f inverse of 3.5. Well, 3.5 gives us a value of negative 1 and negative 2.5. Then f of 2 would give us negative 1. And then f inverse of negative 1 could give us 2, or it could give us negative 5. So there could be multiple outputs. It could be an output that gives multiple inputs. So outputs are allowed to repeat. Well, the definition of inverse function is it takes a known output and pairs it with its corresponding input. So it's denoted by f, and then this little, it's not a power of negative 1, it's just our notation for f inverse, okay, of x, and that's how you read that, f inverse of x. So if like an apple gets put in the function and it turns into a banana, then f inverse would turn the banana back into the apple. And so that's kind of what's going on with inverses. So you could write that f of f inverse of x is just x. So f inverse is going to find the input, and the input's going to take us straight back to the output again. And so f inverse of f of x is also just x. So if you apply f inverse and f to a value, you just get the value back. Okay? So here's some examples for you. So j inverse of 5. So now in the j table, I'm looking for 5 in the output, and I don't see one. So we would say this does not exist. Okay? F inverse of 21. Well, to do that, we're actually going to have to solve an equation. So I know that f inverse of 21, that 21 came from 4x minus 11. So my question then is, what value of x is going to make 4x minus 11 equal to 21? So I'm going to take this function and set it equal to 21. I'll add 11 to both sides, and that gives me 32, and I'll divide by 4, and that gives me 8. Function a inverse of 1. Well, a is this table. So I'm looking in the outputs for 1. There it is. And so the corresponding input is 4. P inverse of negative 2. So if you go to negative 2 on output, you see that there is no corresponding graph at that point. Right? There's no point that has a y-intercept or y-coordinate of negative 2. So this is another D and E. Does not exist. A inverse of 3. Well, here's 3. And its inverse would be 0. h inverse of negative 7. So I'm going to take h and set it equal to negative 7 and solve. I'll subtract 5, and then I'll divide by negative 6. And I'll get 2. P inverse. Well, P is, though, this graph again here. So P inverse of 1. So if you go to 1, and then you look left or right, you're going to see there are two values. Positive 1 and negative 1. Okay, we probably need to put an and statement there. 1 and negative 1. Okay. M inverse of 1. Well, here's 1. Look left and right. And there it is, right there. We'll call it 2.5. Excuse me, negative 1.5. Halfway in between, just rough estimate there. F inverse of 1. F is a function up here, an algebraic function, so I'm going to take that expression, set it equal to 1, and see what x value I get out of that. So I'm going to add 11 and get 12. I'm going to divide by 4. I'm going to get 3. So an input of 3 gives an output of 1. Q inverse of negative 5. Well, Q is this function 1/4 x plus 5. So I'm going to do 1/4 x plus 5 equals negative 5, and then I'll subtract 5. I'll get negative 10, and to get rid of a 1/4, I'm going to multiply by 4. So x equals negative 40. Okay, hope you understood all those examples, tables, graphs, and equations. There's an assignment in Delta Math. It's going to ask you to do a couple skills, and then there's an assignment in Formative that's going to help you do some inverse function evaluation.